So in a typical TCP three-way handshake, the client sends a SYN packet to the server. The server responds with the SYN ACK, and the client then returns with an ACK to the SYN ACK, at which point the connection is established. The problem in a typical TCP three-way handshake is that the client can send a SYN and cause the server to allocate a socket buffer for that TCP connection, but then if the client never returns, the client can force the server to allocate many socket buffers simply by sending a lot of SYNs and never returning. In fact, these could even be from spoofed IP addresses. So in other words, the client has absolutely no accountability and no obligation to return to send the final ACK, and yet can cause the server to allocate resources. This is a problem, and the solution to this is called SYN cookies. In the TCP SYN cookie approach, when the server receives a SYN from the client, the server, instead of allocating a socket buffer for the tuple associated with the connection, the server keeps no state and instead picks an initial sequence number for the connection that's a function of the client's IP address and port and the server's IP address and port, as well as a random nonce to prevent replay attacks. An honest client that returns can then reply with an acknowledgement with that sequence number in the packet. The server can check that sequence number simply by rehashing all of the information that it already has, thereby determining that the acknowledgement here corresponded to the previous SYN ACK that it had sent the client, without requiring the server to store any state. Only if this sequence number matches the one picked by the server in the SYN ACK does the server actually establish the connection.